A lot of people on the channel have been asking me to do a proper demonstration of the Kiraa Engine. It's a fair question, but up until now, it's been a little bit awkward. Firstly, because we're running sensitive data for customers, I'm sure you can imagine they don't want their data plastered all over YouTube. And also, some of the things that we process won't make sense to people outside that industry. But I wanted to build a demonstration that everyone could relate to, and I haven't really had the bandwidth to do that. But with a few big things out the way now, I sat down this weekend to wire up a prototype. So in this video, that's what I want to show you today. Weather's actually a really good proxy for enterprise data because it has much of the same shape as the problems that our customers actually have. It arrives very frequently, every hour, every day. It's multidimensional. It's by place and time. It has actuals and forecasts. So here's the brief that I wrote for myself. For every postcode in Australia, I want to pull in the observations of what weather actually occurred and then forecast what was predicted. And the actual versus forecast split is part of the interesting part here. We want to measure not just what happened, but also to see how good those predictions were. So to make this interesting, I wanted to pull in 6 different measures: rainfall in millimeters, hours of sunshine, maximum temperature, minimum temperature, and wind speed and humidity. And then I want to take each of those metrics and run it across a ladder of time windows. Short range, today, week to date, full week, month to date, and calendar windows every month this year and the same months last year. And then I want rolling periods, 3 months, 6 months, 12 months. And the extremes, I want the hottest and the coldest in every window. And then I want comparisons year on year. Is this month wetter or drier than the same month last year? How far off was the forecast to prediction, etc. So to put that into perspective, we've got a set of metrics with multiple time windows, actual and forecast this year and last year, across around about 3,000 postcodes. And that's roughly 32 million data points feeding into 8.5 million cells of analysis. And out the other end, we have a finished weather report per postcode, plus a couple of rolled up summaries that help us visualize that more generally. So doing this the traditional way would be spinning up a cloud warehouse, orchestrating pipelines, clustering jobs. I mean, something like this would take you hours on a really high-end GPU to match. So I've done this on my Mac M4 laptop here. The whole job is taking over an hour, but I haven't really even started on the optimization yet. And for a lot of the really heavy work, it's still very CPU heavy. And once I've got it working the way they want, I'm going to start offloading parts of that onto the GPU. But let me just do a quick walkthrough of what the engine is and what I've built. Okay, so I'm starting up the Kiraa Engine. Let me first just go into the articles tab just to see that I don't have any local articles, so that's all clean. So we're coming from a clean slate. Now let me go into the weather analysis prototype that I set up this weekend. I'm just going to submit the first job here, which is a weather report for all postcodes in Australia. It's currently constrained to only the capital cities, but that job's been submitted. And what I'm expecting to happen at the end of this is that we'll have individual postcode weather reports for 8 postcodes in Australia. There's actually about 3,500 postcodes, but I've just chosen 8, so I don't have to wait around too long. Okay, the job's just been picked up now. So the job, when I submitted the job, it went into the job queue. The job queue will allocate the job to the first available machine in the fleet. So if one of my other team members had their laptop on, the job could have gone onto their computer as well. So the idea is that we're pooling our GPU resources within the company, so anyone can pick up any job of the right sort of specification for their machine. But this job has been picked up by my machine because I can see that it's got a little rainbow around it. So the square around the job indicates it's running on mine. If someone else starts submitting jobs, I'll see their jobs as well at the top, but they won't be highlighted. So the job's currently sitting at about 15%, so I'd expect this to take around about just about 4 minutes 50. I think the last test was around 4 minutes 50, so I'm not expecting it'll be too different from that one. So now that's before optimization. So the last full run took around about an hour. The thing with GPUs often as well is small workloads actually can be worse on GPUs. So you need a certain level of scale before it actually makes sense. So there's actually a high fixed cost on GPU calculations. So you've got to make sure that you sort of approach it at the right level of activity. And 8 postcodes is probably more of a cost than an advantage at this point. So the job's sitting there. There's not too much load on my computer. So it's, as I said, I haven't optimized this job yet. So I'm not making use of all the cores. I'm not making use of the GPU. So it's still only cantering along at the moment. I don't like to do that until I've got all of the processes working and debugged. It gets too hard. Just have a quick check at the job lists. Oops. Sorry. Yep. Yeah, cool. Running. It's all good. Excellent. So let me now jump back into the job queue. Just see, it hasn't updated too much, so I'm expecting it to jump to 30% before too long. As you can see, I've had quite a few failures along the way to get this to the point that I'm happy with. But I mean, I only started on this morning. I did a little bit of the design work on the algorithm yesterday, so it's really only been a couple of hours yesterday and all of today that I've managed to get this together working. It's probably going to be a bit boring for a few minutes, so I may fast forward for some of this. Okay, that looks like it's done. Excellent. Let's have a quick look. Job log. Yep. A quick scan through. That's okay. Right. Let's confirm that's done. Yep. Right, so it's down the bottom. Any issues here? All looks good. So it's generated the articles as I'd expected. Just on 5 minutes, not too bad. Cool. Let's go to the articles. Right, and now I should see the individual postcode articles generated there. Yep. Okay, where's that chart? Yep, okay, cool. That's good. And so these articles have all been generated through that process. So it's done all the calculations, all of this has been generated as a result of that job that we just completed. So the objective obviously would be to be able to build this out in more detail, add more forecasting, live data feeds, infographics, anything that we needed to make that information more digestible. Yep, random on machine, all looking pretty good. Still quite a bit I could do to optimize this, but this was my first working draft. I know a full run takes me just a bit over an hour, but I'm really happy with that. That's awesome. Yep, not much of a load there at all. So we got a lot of opportunity there to get that down a lot. I can just also now maybe just submit the other one just for testing. But yeah, that's just a quick run through of what I've built this weekend using the Kiraa Engine. I hope that is useful. It's obviously just a prototype, but what I really wanted to show you was the ability to build on top of stuff, so we can ideate really quickly. We just don't have to worry about a lot of the back end infrastructure. That we can just hook that straight. So that's really interesting. But what I want to take you away from is not the weather itself, but how quickly this went from an idea to a working prototype that I can now show partners. And the only way I could do this was because I'm not starting from zero. The hard parts were already done. The Kiraa Engine, the analytics function, the aggregation logic, all that's already written and tested and optimized for Apple Silicon. So a new integration is not an engineering project. It's more a configuration exercise, defining the data, defining the metrics, understanding the time windows, etc. So this integration is running on synthetic data right now. It's deterministic and based on geography. But Darwin doesn't behave like Hobart, etc. So it's not yet wired to any live data source. That's the next phase. And most of the heavy lifting of the algorithm still leans on the CPU. The engines are built for metal, but I need to move some of the functions off to the GPU shaders so that we can run thousands of postcodes in parallel. So the target, once that is done, is probably the whole country in about 10 to 15 minutes. So what I built this weekend is a national weather analytics run. Every postcode using actual and forecasts, thousands of metrics on a single device in a weekend. And that's really the whole power of the Kiraa engine. We can now build these things much more quickly because a lot of the heavy lifting has already been done. So that's the beauty of Kiraa. I'm Dr. Errol Brandt, the founder of Kiraa. If you enjoy my content, please like and subscribe. Feel free to connect with me on LinkedIn, and I'd love to hear your thoughts in the comments below. Thanks for watching, and I'll see you in the next one.